Hello everyone, welcome back to my channel. In today's video, we'll cover question 9, which has two important parts. Here we'll discuss part A. We'll learn how basic logic gates are obtained from the neural networks, and we'll clearly understand the number of neurons, activation functions, and the need of backpropagation. Let's begin. A neural network neuron works exactly like a mathematical function. It takes input, multiplies them with weights, adds a bias, and passes the result into an activation function. The equation of the neuron is output equal to activation weighted sum plus bias. Now using the simple structure, we can implement logic gates. First gate is AND gate. For an AND gate, it requires one neuron. It is single layer neural network. It uses positive weights and negative bias. The activation function used is step or sigmoid function. It is linearly separable, so backpropagation is not required, and this means that AND gate can be directly designed using fixed weight without any training. Next is OR gate. The OR gate is also implemented using one neuron, single layer network, and small positive weights and small negative bias. Step or sigmoid activation is used and it is linearly separable. And again, backpropagation is not required. So both AND and OR gates are the simplest example of the neural networks. Next is NAND gate. So it also requires only one neuron, single layer network, uses negative weights and positive bias, and activation function is again step or sigmoid function, and it is linearly separable. No backpropagation is required. This showed that even inverted logic can be handled by a single neuron. Next is NOR gate. The NOR gate follows the same pattern. It has one neuron, single layer, negative weights and negative bias, step or sigmoid activation, linearly separable, and no backpropagation needed. Till now, AND or NAND and NOR can all be implemented using a single perceptron. Next is XOR gate. Now comes the most important gate, XOR. For XOR gate, it requires 2 to 3 neurons. It needs a multi-layer neural network. Weights cannot be fixed directly. Uses a sigmoid or ReLU activation. It is not linearly separable, so backpropagation is required. This is very important that XOR cannot be implemented using a single neuron because the data cannot be separated by one straight line. The last one is XNOR gate. The XNOR gate also behaves like XOR, requires 2 to 3 neurons, needs a multi-layer network, uses sigmoid or ReLU, and it is not linearly separable. And backpropagation is also required. Both XOR and XNOR always need training and backpropagation. Thank you.